Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Intro to Inverse Operations with Equations. You can follow along with me. We're going to start out with a very important question, which is pretty much a foundation of this entire chapter. What does it mean to solve an equation? Well, here's what it means. When you solve an equation, it means to find the value of the variable that makes the equation true. Another thing that it means to solve an equation is to get the variable by itself. Because if you get the variable by itself, then you're going to end up finding what that variable equals. All right, you'll get like the variable equals and then a number. So that's what it means to solve an equation. Now, the way that we're going to solve equations is by using what the title suggests, and that is the idea called inverse operations. Now, what does that mean? Well, first of all, let's make sure we understand what the word inverse means. The word inverse means the opposite of the original. So the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. This is what I mean by inverse operations. Operations, that word operation refers to in math addition, subtraction, multiplication, and division. Now, like you saw on the guided notes called Working with Equations Like Their Balances, whatever we do to one side, we must do to the other side. So, that's going to be key today. We have to do things to both sides of the equation just like you would with a balance. Whatever you do to the left side, you must do to the right side. And the equal sign is what separates the left side from the right side. So whatever we do to the left of the equal sign, we must do the same thing to the right of the equal sign. But today, we're not going to do something random on both sides of the equation like we did on the other guided notes called Working with Equations Just Like Their Balances. Today, we are going to specifically be doing these things called inverse operations. Now, I would not suggest doing inverse operations for every single equation. I would only do them when the variable is not by itself, which is what you're going to be seeing on all the equations today. Like, for example, the very first one, number 1, you can see the y is not by itself. It has a plus 18 next to it. So this is what I mean. We're going to use inverse operations to get those variables to get by themselves. Okay, some keys to success. You will always inverse the operation, meaning we're always going to be talking about the inverse of addition or subtraction or multiplication or division. It's the operations, those 4 operations. Those are what we're going to be focusing on when we do the inverse. We are not going to inverse any number today. So this is not about making the numbers go from a positive to a negative or a negative to a positive. No, 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 no. When we talk about inverse operations, we are specifically talking about the inverse of addition, subtraction, multiplication, or division. Now, something else you need to remember. Subtraction is the exact same thing as adding the opposite. Subtraction is not the inverse of adding the opposite. Adding the opposite is not the inverse of subtraction. Subtraction is the exact same thing as making it become adding the opposite of the very next number. So we're talking about 2 different things here. We're talking about inverse, which does mean the opposite of the original, and then we're talking about subtraction, which is the same thing as adding the opposite. All right, let's finally take a look at what we're going to be doing specifically today. There's 4 parts to the directions. Follow along with me. We're going to ask ourselves and answer the question, what's happening to the variable? A very important question. If you don't know what's happening to your variable in the original problem, then you're going to be, shooting in the dark as to what you need to actually be doing to solve the problem. Next question, just as important as the first one. We're going to ask and answer, what's the inverse of that? So if the variable is going to be added by something, we want to figure out what's the inverse of that adding, which of course would be subtracting. If the variable is being multiplied by something, then of course we're going to do the inverse of that, which would be dividing. This is how these first 2 questions are going to play out. Third thing, whatever the inverse operation is, Whatever we figure out as the answer to the second question, we're going to do that inverse operation underneath the equation on both sides, meaning both sides of the equal sign, just like a balance. Then, fourth thing, any place that we see subtraction, whether it's on the original equation or if it somehow ends up in our inverse operation that we're doing on both sides, we're going to make the subtraction become adding the opposite. That's the fourth thing we will do. Now, you will notice there's not a fifth part that says finish solving the problem. And that might surprise you today. We're actually not going to end up finding the value of the variable today, which might seem counterintuitive since I just spent the top of the notes talking about finding what the variable has to equal to make the equation true. I promise you on the next guided notes, we will finish solving the whole way. But I have learned that these four parts, asking what's happening to the variable, what's the inverse of that? I used to assume that kids could just do that naturally, and I learned, no, I need to teach them the process. So that's why we're taking our time through this process. We're actually not going to focus on solving the whole way. We're just going to focus on these four parts. All right, let me go ahead and lead you through like 3 or 4 examples here, just so you can get the hang of each of these four parts of the directions. So the first part of the directions is we're going to ask and answer what's happening to the variable. Now, when I answer what's happening to the variable, that doesn't mean what is the variable. Like number 1, the variable is y. Of course it is. It doesn't mean what does the y represent. We know that the y represents an unknown number. That's not what we're asking. We're asking what is mathematically happening next to that y in our equation. What's happening to the variable? And as you can see on problem number 1, the y has a plus 18 right next to it. So, pencils in your hand. Let's write this in words. The variable, what was happening to it? It was being added by 18. We are going to use the word by, okay? Because that describes, then we're talking back about the variable. The variable was added by 18. Okay, what's the inverse of that? When I say the pronoun that, I am referring back to whatever I just said was happening to the variable. So what's the inverse of adding by 18? Well, the inverse of adding is subtracting. Now, should I also make the 18 change to a negative? No. Remember what I had here in the key to success. We will inverse the operation. We will not inverse the number. Not inverse the number. So, back to problem number 1. If the variable was being added by 18, then the inverse of that is to subtract by 18. You are not making the 18 become, its additive inverse. You're not going to make it become a negative here just because it was positive. No, 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 no. The inverse of adding is subtracting. That's what gets inversed. Now, third part of the directions. Write this inverse operation underneath, meaning underneath the original equation, on both sides. So what are we writing underneath on both sides? We're writing the inverse underneath on both sides. What was the inverse? Subtracting by 18. That is what must get written underneath the equation on both sides. Go ahead and write it down. Now, please remember the equal sign separates the left side from the right side. So I don't know if you want to put it like a dashed line through this. Don't put a solid line because I don't want you to think that we're saying it's not equal to. Don't do that. I just want you to realize the equal sign is what separates the left side from the right side. You will notice I am subtracting by 18 underneath the equation on the left, and I'm subtracting by 18 underneath the equation on the right. And I put that result bar underneath because if I was going to finish solving the problem, then we would put those results underneath, which we're not going to do today, but eventually in the next guided notes we will. So step 3 has now been done. I took the inverse, which I originally wrote in words, subtracting by 18, and I am doing it underneath the original equation on both sides. If you don't want to draw the dashed line through the equal sign, you don't have to. I just want you to know there's a left side of the equation, which means to the left of the equal sign, and there's a right side of the equation, meaning to the right of the equal sign. All right, the fourth part of the directions is to make any place where we see subtraction become adding the opposite. Do we have subtraction on the original problem? Nope, that was a plus sign between the y and the 18, so that's not going to be made adding the opposite. Is this dash on the 4, is that a subtraction? No, because to the left of it is just an equal sign. You can't be subtracted from an equal sign. So that was actually a -4. So that's not subtraction. But what about these dashes that I just wrote underneath here? Well, they are subtraction. How do I know? Because remember what that came from. That came from me saying that the inverse of adding was subtracting. So that actually is me subtracting by 18 underneath the equation on both sides. So here we go. What do we do with that subtraction? We make it adding the opposite. We'll do it there on the left side where we had subtraction, and we'll also do it on the right side where I was subtracting by 18. So that also gets made adding the opposite. So make sure you're doing that at both places, just like I did it with my blue little slashes here, making subtraction become adding the opposite. Now, if the fifth part of the direction said finish solving the problem, then we would work down on both sides, just like we did on the guided notes called working with equations like their balances. But we're not doing that today. We're just focusing on these 4 parts. All right, let's do problem number 2 together. Starting with what's happening to the variable. Well, where's our variable? There it is, m. M is being subtracted by 6. So, boom, we'll write that down. It's being subtracted by 6. What's the inverse of that? Meaning, what's the inverse of subtracting by 6? Well, the inverse of subtraction is adding. Should I make the 6 become its opposite sign? No. We're inversing the operation. The operation of subtraction, its inverse is addition. That's the only thing that changes when you identify the inverse. That's it. So, what do I do on both sides? Well, the directions clearly say that the third thing is to write the inverse operation underneath on both sides. So what did I just say was the inverse operation? I said the inverse was adding by 6. So that is what we are going to always do. Whatever the inverse is, that's what we're going to do underneath the equation on both sides. Remember, the equal sign separates the left side of the equation from the right side of the equation. So we will add by 6 on the left. We will add by 6 on the right. Please do not think that we're rewriting an equal sign underneath or the variable underneath. No. We're just trying to show that we are adding by 6 underneath the equation on both sides. And please line it up correctly. Like, don't put the +6 under the variable, because remember how whenever you add or subtract, you always have to add or subtract like terms. So put the +6 underneath the -6. That's where it must go. And then, of course, underneath on the right side. All right, what's the fourth part of the directions? Fourth part is to make any place where we see subtraction to make it adding the opposite. So do I have subtraction on my inverse? No, that's adding by 6, So that's not subtraction. But the original equation this time has subtraction, m minus 6. So boom, make that adding the opposite. And that thing to the right of the equal sign, that was not subtraction, that was -97. So there you go. That's the 4 parts of the directions being done. All right, let's do one more together. Problem number 3. We have a minus -8 equals -3. What's happening to the variable? Well, my variable is a. What's next to it? It's being subtracted by -8. Now, make sure you are writing down that it's being subtracted by -8. Yes, that negative, that's a negative right there. It needs to be there. Do not accidentally write down subtracting by 8. It's being subtracted by -8, all right? That's what that meant. Okay, what's the inverse of subtracting by -8? It's adding by -8. Notice it's still negative because we are not inversing the number. We are inversing the operation. That's why the title of your guided note says inverse operations. The word operations refers to addition, subtraction, multiplication, and division. That is what operation means in math. So that's what we are inversing today, not the sign of the number. I apologize that I keep repeating that, but I want to make sure you fully understand what we're doing and what we're not doing today. Okay, what are we going to write underneath the equation on both sides? It's the inverse that always gets written underneath. And the inverse, we already said, was adding by -8. Now, please be careful. Every year that I do this problem with my class, I have some students who, for whatever reason, don't put the negatives on the 8s, or they don't put the addition sign with it, and I'm not entirely sure why. We specifically wrote that the inverse was add by -8. So make sure that is exactly what you are doing underneath the equation on both sides of the equal sign. What is the fourth step? The fourth step is any place we see subtraction, make it adding the opposite. So where do we see subtraction? Not on our inverse. Our inverse was adding by -8 underneath on both sides. But on the original problem, we see a minus -8. And I hope you guys know, whenever there's only a number inside, coming to the right of like a minus or plus, then the parentheses really don't matter in that situation. Now, if there was a number sitting right next to the parentheses outside, that'd be multiplication, then the parentheses would matter, but that's not what we have here. So those parentheses do not really matter. And therefore, when you make subtraction become adding the opposite, that's going to make it adding a positive 8. Please do not make it become a plus -8. I see some kids do that where they want to put a negative sign outside of the parentheses. No. Don't do that. That's complete nonsense. Okay, that's 3 problems that we now did together. I would now love for you to try number 4 on your own, but I do want to get you started just on the very first part. What's happening to the variable? I threw a curveball at you here. Instead of putting the variable on the far left at the very beginning of the equation, I have the variable to the right of the addition sign. So to answer what's happening to the variable, you would have to read from right to left. You'd have to kind of read backwards. Is that okay? Well, it depends. If there's subtraction, you cannot read backwards. If there's division, you cannot read backwards. But if it's addition or multiplication, you can read forwards or backwards. It wouldn't matter because of the commutative property. So what I'm basically trying to tell you is that -21 plus r is actually the same thing as r plus -21. They are the same thing. The order of addition does not matter. So with that being said, when we answer what's happening to the variable, we can read backwards and we can say the r was being added, right? There is an addition sign next to it. It was being added by what? By -21. All right, hit pause on the video. Do the other 3 parts of the directions for number 4 right now by yourself. All right, I hope you did the second, third, and fourth part of the directions by yourself for number 4. Let's see how you did. Pencils and erasers ready. So, did you determine what the inverse was of adding by -21? You should have said subtracting by -21. Notice how the negative did not change. We are only inversing the operation. The inverse of addition is subtraction. Now, what are you supposed to write underneath on both sides of the equation? You're supposed to write subtracting by -21. Did you actually write that down on both sides? Because every year that I give this problem, I have some students who think that all they have to write is subtracting 21. And that is wrong. Do you see why that's wrong? It says that the inverse is to subtract by -21. You need both of these slashes, you need the one that represents the subtraction. Okay? That would be this guy and this guy here. But you also need the negative sign. So, can you please check right now very carefully, because I've seen so many kids not write this correctly every year I give this problem. You need to have subtracting by a negative 21. 2 slashes, both, one for subtracting, the other for a negative, on both sides. And do you have it lined up properly? I know I'm being really picky today with this. You better have the minus negative 21 underneath the other negative 21 that was on the original problem. Do not write it underneath the R, because that would not be lining it up properly with the idea of how you can only add or subtract like terms. So please line it up properly. All right, I have a lot of highlighting up here. Let's get rid of all this highlighting craziness. Okay. So we subtracted by negative 21 on both sides. Fourth part of the directions, make subtraction, adding the opposite. Our inverse operation was subtracting by negative 21. So we're going to make that adding the opposite on the left side and adding the opposite on the right side. Ladies and gentlemen, you better not make the negative 21 in the original problem become adding the opposite, or the negative 9 in the original problem become adding the opposite, because those were negative signs. They should not be made adding the opposite. Only subtraction becomes adding the opposite. Okay, the second page of the guided notes is meant to pretty much be independent practice. But I do want to quickly have you jump down to number 7, and I want to lead you through it real quick. So here we go. Skip down to number 7. We're on the second page. What's happening to the variable? Well, this is not addition or subtraction, is it? The 7 is right next to the y. What does it mean when a number is right next to a variable with nothing in between? It means multiplication. So the y was being multiplied by 7. Yes, you can abbreviate the word multiplied if you want, just like I did. What's the inverse of multiplying by 7? Well, of course, it's dividing by 7. Notice the 7 did not turn negative. The inverse of multiplication is division. We are not inversing the number. Underneath the equation, we are going to do the inverse operation. What did we say the inverse was? We said the inverse was dividing by 7. So that's what we do underneath the equation on both sides. Is there any subtraction to make adding the opposite? No, there's not. There's no subtraction on number 7. None. That dash next to the 98 is a negative 98. That is not subtraction, because the only thing to the left of it is an equal sign. This is how I know it's not subtraction. So that's it for number 7. We have actually done all 4 parts of the directions. It's just that the 4th part, making subtraction adding the opposite, did not even apply on number 7 because there was no subtraction symbol. And I also want to do number 9 with you before I have you do the rest of the problems on your own, because this one's a little unique looking. You see how the variable is in the numerator of a fraction? That's a fraction bar, and a negative 5 underneath it. So how do I answer what's happening to the variable? Fractions mean division. So the h is being divided by the negative 5. You can abbreviate the word divided if you would like. What's the inverse? It would be multiplying by negative 5, because the inverse of division is multiplication. Notice the negative is still there. So let's do what we said the inverse was, which was multiplying by negative 5. Let's do that inverse underneath the equation on both sides. Please double check that not only are you putting times dots, but you also have the negatives on those 5s. Every detail matters today, guys. Every detail. And there you go. Oh, is there any subtraction to make adding the opposite? No, there is no subtraction on number 9, just like there was no subtraction on number 7, because this was a multiplication or division problem. There was no subtraction on it. So there's nothing to make adding the opposite. Okay. I would like for you now to do all the remaining problems on the second page by yourself, which would be numbers 1 and 2, then 3, 4, 5, 6. We already did 7, then you'll do 8. We already did 9, you will do 10. Hit pause in the video, do those remaining 8 problems on your own right now, then hit play when you're ready to see how you did. Okay, I hope you have already done 1, 2, 3, 4, 5, 6, then also number 8, and then also number 10. Let's see how you did. Get your pencils and erasers ready. Pay attention to every single detail. Problem number 1, what's happening to the variable? It was being added by 81. Inverse, subtract by 81. Is that what you did on both sides? The inverse, subtracting by 81. Now, do we have subtraction? Yes, we do. Make it adding the opposite there, and make it adding the opposite there. The original problem did not have subtraction, so that doesn't get touched to be made adding the opposite. Problem number 2, what's happening to the variable? It was being added by negative 39. What's the inverse? Subtracting by negative 39. Now, this is the one you got to be really careful. You need to have a dash for the subtraction, but you also need to have the negative symbol on the 39. So, can you please double check that you indeed subtracted by a negative 39, not just subtracting by regular 39. You need to have both the slash for subtraction and the other one for the negative. Okay, last part of number 2. We make subtraction become adding the opposite. So we'd make it adding a positive and make the other one also become adding a positive. Problem number 3. What was happening to the variable? It was being subtracted by 28. The inverse is to add by 28. That's what you should have done on both sides. Do we have subtraction on number 3? We do on the original problem. So that becomes plus negative 28. Problem number 4. What's happening to the variable? It's being subtracted by a negative 204. Make sure you have the negative sign. What's the inverse? Adding by negative 204. Please check. Is that exactly what you did on both sides? What we said in words. The inverse was to add by negative 204. That's what you should have done on both sides. Do we have subtraction? Well, on the original problem, we had subtraction of negative 204. So that's going to become adding a positive 204 because subtraction becomes adding the opposite. All right, problem number 5. What was happening to the variable? We have to read backwards on number 5 because the m was written to the right of the plus. So we're going to read backwards and say that it was being added by negative 25. What's the inverse? Subtracting by negative 25. Do you have the negative sign? Please check. You should have done that on both sides. And as I said on a previous problem, you need to have the dash for the subtraction signs. You also need to have the dash for the negative sign. Please make sure you have both. All right, the last thing you'll do on number 5 is find the subtractions and make them become adding the opposite. We have subtraction here. We're going to make that adding a positive. And we also have subtraction on the right-hand side where we subtracted by a negative. So that becomes adding a positive. Problem number 6. What's happening to the variable? It's being subtracted by 27. Inverse is add by 27. Is that exactly what you did on both sides? I hope on number 6 you didn't think the variable was doing anything with the 44. Notice the variable was on the right-hand side of the equal sign. So you always have to find the variable, and whatever is happening to that variable, that is how you answer the question, what's happening to the variable. All right, so where was I? Last part of number 6. Do we have subtraction? Well, yeah. The original problem had w minus 27. We make that adding the opposite. Problem number 7 we already did. Problem number 8, what was happening to the variable was being multiplied by negative 15 because the negative 15 was right next to the variable with nothing in between. The inverse is to divide by negative 15. Now, please pay attention to details. You need to have the negative sign at both places underneath where you divided by the negative 15. Is there any subtraction to make adding the opposite on number 8? No, no, no. There was no subtraction. Problem number 9 was already done. Problem number 10, what was happening to the variable? Well, when it's in the numerator of a fraction and a 72 underneath, then that means the variable is being divided by 72. What's the inverse? Multiply by 72. And that's exactly what you should have done underneath on both sides. Times dot 72 times dot 72. Please make sure your times dots are not too low, because if it's too low, it's going to look like a decimal, like 72 hundredths. So make sure it's a raised dot so it is clearly being shown as a times symbol. And do not use x for multiplication. X is a variable. You need to know that. Please do not use an x for multiplication. All right, that concludes the guided notes on Intro to Inverse Operations with Equations. Thanks for watching. We'll see you next time.